Hello, I'm Elin from Exocad. In this Exoplan tutorial, I will show you the new features in our Exoplan 3.0 Galway release for both the implant planning part and the Guide Creator module. This is the Exoplan DB, and as you can see, with this release we have a new user interface design. Let's first take a look under Settings. Here you can now select between light mode and dark mode. Dark mode looks like this, but I will use light mode in this video. You can choose to activate client as well as technician selection for the DB. You can choose if you want the work types displayed with colorful or minimalistic style. In this tutorial, we will go through the dual scan workflow, which is designed for edentulous cases. For a dual scan case, I need 2 CBCT scans, one of the patient wearing a so-called radiographic guide and a bite index, and one CBCT scan of the radiographic guide alone. I click Implant Planning to start the workflow. The software is intended to be used only by dental professionals with sufficient medical training in dental implantology and surgical dentistry. Do not use the software or DICOM viewer for diagnostic purpose. When the software starts, the first wizard step and the DICOM control opens. But before I continue with the workflow, let's take a look in the settings. The Settings button is located under Tools. In the settings there are some new options. Also here, dark or light mode can be selected. It is possible to define a default folder for where the software looks for the DICOM data. If no folder is defined, the software will search in the project folder. If this checkbox is checked, the safety distances will be displayed as outlines in the cross-sectional images in the implant planning report. You can select to skip the anchor pin step in the wizard workflow with this checkbox. If this checkbox is checked, the density reference definition step will always come in the wizard workflow. If it is left unchecked, the software will skip the define density reference step and use the last defined values. You can set an insertion depth for the anchor pin. This will then be the starting depth when you place the pin and can of course be changed during the placement step. Here you can select which alignment workflow you want to set as a default. You can also select if a fixation guide should always be created or not at all created, or if you want to make the decision for each case. I start by loading the patient CT scan. I have not defined any DICOM default search directory in the settings, so the software directs me to the project folder. I can still of course search and load it from any location. 3D CT input data shall have sufficient spatial resolution and be of high quality to allow to recognize all relevant anatomical structures. Since I have checked the box for density references under Settings, this step is now the next in the workflow. When you use the software for the very first time, this step comes even if the box is not checked. Here I can define thresholds for soft tissue, bone, and tooth. Move the slider to the desired value and click the Define Value button. The value is saved and you can use the corresponding button in the DICOM control to visualize it. The DICOM control is explained in detail in a separate video. You can also define the threshold to display dense parts blue and less dense parts red. This can be used as a guideline when placing implants later in the workflow. When the last value is defined, the software continues automatically to the Define Panoramic Curve step. A new feature in this step is the automatic curve detection. When the box is checked, the software will automatically define the curve in the current slice. You can scroll through the slices with the mouse wheel when the cursor is in the upper part of the screen. In the lower part of the screen, you see the panoramic view, which changes with the curve. Since this is a maxillary case, I will define the curve in the upper jaw. As you can see, the software displays a U-shaped curve if it cannot detect enough bone to define a curve automatically. You can manually define the curve by moving the existing control points and by placing new control points by clicking the left mouse button. As soon as you change the curve manually, the automatic curve definition is deactivated. You can activate it again by checking the box. Use the slider to change the X-ray noise threshold in the panoramic view. Continue with Next. In this step, you select which type of alignment workflow you will use. This step comes when you have the setting Ask in Wizard Workflow selected in the settings under Tools. For this case, I have 2 CT scans and I will therefore select the CT to CT alignment workflow. Continue with Next. The software now asks me to load the CT scan of the prosthesis, that is, the CT scan of the radiographic guide. When the CT scan of the prosthesis is loaded, it is very important to set the surface threshold to a correct value, rendering the image to look as the real prosthesis. As a help, I can use the secondary views. I set the threshold so that the complete prosthesis is colored in. You can use the different visualization modes for the secondary views to switch between the threshold visualization and the plain CT visualization. I check in the 3D view to make sure that the visualization looks correct. The most important parts are the areas that will be in contact with the patient's gingiva and the teeth that needs to fit into the bite index when the guide is placed in the patient's mouth. Thereafter, I extract a mesh for the selected surface threshold. If this checkbox is checked, the software continues directly to the next step when the extraction is done. If it is not checked, the software stays in this step until you actively click Next. This gives you the chance to go to the second tab in this step and edit the extracted mesh. Use the free-forming tools and/or the Edit Mesh tool with great care. It is very important to make sure that the areas affecting the fit of the final surgical guide in the patient's mouth are not altered. When Next is clicked, the software continues to the alignment step, and the alignment is automatically performed over the RadioPARC markers present in both patient scan and prosthesis scan. I check the accuracy of the alignment with help of the secondary views. I compare the position of markers and check that the mesh outline is correlating with the markers in the patient scan. I scroll through the data by holding the right mouse button pressed and moving the mouse in the direction indicated by the arrows shown in the secondary view. If needed, I can switch to manual alignment and carefully adjust the alignment. I can move and rotate the prosthesis mesh in both the 3D view and in the secondary views, except for the secondary view panorama, using the left mouse button for moving and control button plus left mouse button for rotating. It is also possible to move and rotate the mesh using the arrow keys plus control key on the keyboard. With this slider, you can set a step size for the movement done with the arrow keys. Aligning the CT data is a sensitive process which must be performed accurately. Click here to accept and evaluate the manual alignment. In this case, I will undo the manual alignment completely, since the automatic alignment worked perfectly. I will now go back one step to the part of the alignment that the software automatically performed. In case the automatic marker detection does not work, the software will halt in this step. Here you have the possibility to manually add or delete markers in the CT scans. If you need to, you can use the sliders to change the surface threshold to visualize markers that you want to mark manually. With these buttons, you can add or remove markers. To use the manually placed markers for the alignment, just click Next after you have placed your markers. If you have performed an external alignment and there is no need for alignment within Exoplan, you can switch to the Evaluation tab and select to continue with acceptable external alignment. If you select to continue without acceptable alignment, you can still perform the implant planning, but you will not be able to continue to design a surgical guide until an acceptable alignment has been done. You can return to this step later over expert mode to perform the alignment. To restart the automatic marker detection, click the Start Marker Detection button and confirm that you want to discard your manually made changes and continue with the automatic detection. This automatic alignment is good, and I will continue with acceptable alignment. In the sinus segmentation step, you can define the sinus cavities as collision objects. This step is part of the wizard workflow if you have defined implant placement for posterior teeth in the maxilla in the project definition. You can access the step over Expert menu for any case if you'd like. If you don't want to mark the sinus, you can skip this step by clicking Next and selecting Skip. To create a collision object that represents the sinus cavity, move the slider to visualize a threshold. Set the threshold so that the sinus cavity is clearly distinguished in the secondary views, and click with the left mouse button in the middle of the sinus in one of the secondary views. Then start the segmentation and click the corresponding button to create a collision object from the segmentation. If the segmentation does not detect the complete sinus cavity, you can edit the created collision object using the freeforming tools under the second tab. You can freeform the mesh both in the 3D view and in the secondary views. Hold Tab pressed when you want to remove material or flatten material. Scroll in the secondary view to adjust the mesh on more areas. Continue with Next. In the implant positioning step, we now have a new implant selection dialog. Click on the tooth number for which you want to place an implant to open the selection. At the top of the selection dialog, you have a search field where you can type in anything to search in the installed libraries. You can select to search among all installed libraries or to search only within the ones you've marked as favorite. If you want to install more libraries, use the Download More button, which directs you to the download portal on the exocad website. Below, you have all your installed implant libraries listed. To mark one as a favorite, click the star. At the bottom part, you have all the manufacturers of the installed libraries listed. Click on the manufacturer to show only the libraries from that manufacturer in the implant list above. If you then click on Favorites, only your favorites from the selected manufacturer are shown. Click on the implant you want. The dialog now shows you the available diameters and lengths for the selected implant. Select the diameter and length that you want. A preview and details for the selected implant is shown. Click OK to select the implant, or if you have compatible CAD libraries installed, you can also select to place an abutment or tie base in this step. Click on the corresponding button and select what type of prosthetic part you want to place. You will see a preview of the selected part in the window below. You can place the implant first and thereafter select the prosthetic part if you prefer. When I place an implant, I prefer to first roughly place it in the secondary view curve cut, the secondary view with the blue frame. To focus the secondary view to the area of interest, I click with the mouse wheel on the denture tooth 1/5 in the 3D view. After that, I place the implant in the secondary view curve cut by clicking the left mouse button. As soon as I have placed the implant roughly, the secondary views changes to the implant-centered secondary views, implant cross and implant axial. I use the arrows in both the 3D view and the secondary views to modify the position of the implant. To enlarge the secondary view, click the Focus Unfocus button. I scroll the secondary views by holding the right mouse button and moving the mouse in the direction indicated by arrows in the view. To enlarge the 3D view, click the Focus Unfocus button in the enlarged secondary view. To place the next implant, click the tooth number to select an implant. The previously placed implant type is already selected. Just click OK to place the same type as before, or select a different implant if desired before clicking OK. You can select a different length by dragging the arrow up or down. You can select a different diameter by holding Shift and scrolling the mouse wheel when the mouse cursor is over the active implant. Now that I have placed the second implant, I can see the angles between the placed implants when I open the implant control. I can also see the angles between the prosthetic parts. A new feature in the implant positioning step is the possibility to align implants with a few clicks. If you right-click the active implant in the 3D view, you have the option to align the implant direction or the prosthetic part's direction to another implant or to the direction of the prosthetic part of another implant. When I'm switching between implants to adjust the planning, I activate the implant I want to adjust by double-clicking it with the left mouse button. I use the hotkeys to hide and show the scene objects easily without using the Show Hide menu. For example, to hide, hold the Control button pressed and click on the mesh object with the mouse wheel. You can hide and show the CT data with key D for DICOM. A summary of the hotkeys can be found on the Exocad Wiki website. If you have placed an angled abutment, you can select to hold the abutment position fixed and rotate the implant around the abutment. Since I have created a collision object for the sinuses, I get a collision if I come too close to the sinus with my implant. This collision must be solved before I can continue to the next workflow step. Exoplan does not verify if you have placed an implant at an eligible position for the selected tooth number. If you, in the implant positioning step, realize that you need to place more or less implants that you originally planned, you can open the Change Implant Setup by clicking Add Remove Implant. Just make your selection and apply it. Continue with Next. A new feature for Galway is the option to place anchor pins in the planning. If you have selected the CT to CT alignment workflow, this step is part of the Wizard workflow. If you want to skip anchor pin placement, click Next and select Skip. You can of course select this work step from the Expert menu for all types of cases. Select the anchor pin you want from the drop-down list. Move the mouse over the prosthesis in the 3D view and click with the left mouse button to place the pin roughly. Use the arrows in the 3D view and the secondary view to adjust the placement. If you come too close to an implant or a collision object, in this case the sinus, you must resolve the collision before you can continue in the workflow. The anchor pins have a safety distance which can be changed with the slider in the workstep window. To add another pin, use the Add New Anchor Pin button. If you place more than one anchor pin and want to adjust an already placed pin, use either the drop-down menu to activate the pin or double-click it in the 3D view to activate it. Continue with Next. Now we are in the sleeve placement step. Since I selected an implant type that is fully guided, the software places the fully guided sleeves automatically. In this case, not all placed implants have the same diameter and are not compatible to the same sleeves. When working in the Wizard mode, the software starts by placing sleeves for one of the implant diameters first. I continue with Next to place the rest of the sleeves. This system has a fixed distance between the sleeve and the implant, which means that I cannot change the height of the sleeve position. I can rotate the sleeve if necessary. Please note that for some systems, like this one, there is a rotation marker on the sleeve connected to the implant orientation. This means that when I rotate the sleeve, the implant rotates with the sleeve. In the sleeve placement step, I can also choose compatible sleeves from other suppliers if I have the libraries installed. In the drop-down menu, I can select other manufacturers that are offering compatible sleeves. Some manufacturers offer universal sleeves, and if I select that type, I can move the sleeve in the 3D view to a position of my choice. I can also use the manual height and rotation function to type in the exact distance and rotation I want. Note, if you select a universal sleeve, there will be no information regarding surgical kit or drill length in the surgical report. Continue with Next. Now it is time to approve the planning. In this step, we now have a Save Scene button to easily save the scene in case someone else needs to approve the planning. Click the button and give the scene a name of your choice. You can then close the software and send the project over, for example, DentalShare, to the person who will approve the planning. I will instead approve it now directly. The planning result files are written. We can easily look at the report by clicking this button. New in the implant planning report is that we now have the DICOM information from both the patient DICOM and the prosthesis DICOM present. Also, the prosthetic direction angles are shown. At the end, we have the anchor pin overview and detailed information for each anchor pin. I continue with Next to the design of the surgical guide. Please note that manufactured surgical guides for endosseous dental implant placement are classified as medical devices by the FDA. If you have skipped the sleeve placement during implant planning, sleeve placement will be the first step when starting the guide design workflow. When the sleeves are placed, the next step is to design the material holding the sleeves, the sleeve mounts. In this step, we have 3 tabs. The first is for the implant sleeve mounts. New in this step is that you can select how many rotation markers you want to have on the mounts. 1, multiple, or all markers. If the sleeves do not have rotation markers already defined within the sleeve library, you can place custom markers that will correlate to the implant connection's edge or corner. You can select to only show the marker that correlates to the most buccal connection corner or edge, or you can show multiple or all implant connection corners or edges. The second tab is for the anchor pin mounts, which you can design separately from the implant sleeve mounts. The third tab is called Printer Presets. Under this tab you can select if you want to use presets adapted to your printer. The presets will influence the radial sleeve offset, as well as the offset between the bottom part of the guide and the jaw scan. The offset for the bottom part can be adjusted in the workflow step Design Surgical Guide Bottom. If you want to, you can adjust the presets and save them under a name of your choice. To do this, set the slider value to the value you want. Right-click and select Save Preset As. Type in the name you want and save. You will now have this preset available in the drop-down menu for all cases. You can also change the values for an existing preset. Set the slider to the value you want and click the Save button. Now this preset has your selected value saved. If you change your mind and want the original value from the manufacturer, right-click and select Reset to Manufacturer preset. You can download available presets from different manufacturers from the exocad website. I'll continue in the wizard, and the next workflow step is designed for edentulous cases. In this step we have 2 tabs, Contact Surface and Mesh Editing. Under tab Contact Surface, you define the part touching the patient's gingiva and then select your guide design workflow. Under tab Mesh Editing, you can edit the denture mesh. If you want to edit the denture mesh, you need to do this before you start the surface marking. Here I have the possibility to make changes to the mesh created from the CT of the radiographic guide. It is crucial that such modifications are done with great care to not destroy the fit of the guide. I will smooth down the areas where the markers are visible. Since the mesh is created from the DICOM data of the prosthesis, there can be artifacts within the mesh. You can use the mesh editor to cut away those areas, since they could cause problems in the merging of the guide later. For this mesh, it is not necessary. Be very careful when editing the mesh so that the fit of the guide is not destroyed. On the tab Contact Surface, I mark the surface that will be in contact with the patient's gingiva. You can either use the brush tool and paint the contact surface, or you can use the spline tool to outline the contact surface. It is important that you mark the surface correctly. Click on Show More to see examples of right and wrong marking. Below, you decide what type of guide design workflow you want to continue with. You can select between using the marked gingiva surface as base and design the guide freely on this surface. Or you can use the shape of the denture as basis for the design of your guide. I will go through both workflows in this video. First, I will select the Design Guide workflow. In this workflow, the surface area I marked is used as base, and I start by designing the surgical guide bottom on this area. The offset value is already set due to the printer preset I selected earlier when I designed the sleeve mounts. I can still change it if I want, and the slider area then turns pink to signal that the selected value differs from the preset value. I select the insertion direction and click Apply to create the surgical guide bottom. I continue with Next and can now draw a curve to mark the outline of my guide. As a help, the prosthesis mesh is shown, but if you don't need it as a guideline, you can easily hide it by using the hotkey Ctrl plus mouse wheel. You can use this hotkey to hide any mesh object in the 3D view. Place the mouse cursor on the object you want to hide, hold the Ctrl button pressed and click on the mesh object with the mouse wheel. To show the object again, hold Shift plus Ctrl and click with the mouse wheel. Click Apply or Next to generate the surgical guide top mesh. In the next step, I can place attachments to the surgical guide. A new attachment type for Exoplan 3.0 Galway is the Mount Connector attachment. Just click on two mounts that you want to connect, and the software adds a connector. If the mounts are close enough, the connector gets a nice organic form. Also new in this release are the arrows to easily rotate the support and window attachments. It is also possible to morph the shape. Hold both Shift and Ctrl pressed and move the mouse to morph the shape of the attachment. Continue with Next. The surgical guide is now merged, and when the merge is finished, I can select if I want to create a fixation guide as well. For this case, I will definitely do that, since I will not be able to use the bite index to find the correct position of the guide in the patient's mouth with only this surgical guide. Before the fixation guide is created, I have the option to do some free-forming on the surgical guide. When I start to create the fixation guide, I must decide how I want to handle the attachments I placed for the surgical guide. I can select to keep them, and they will then be placed on the fixation guide as well. Or I can ignore them, which means they are not placed on the fixation guide, and I can start fresh and place new attachments. If I don't want to place any attachments at all on the fixation guide, I can select the last option, and the attachment step for the fixation guide will then be skipped. I will select to keep the existing attachments now. As you can see, I get the denture mesh as the base for my fixation guide. In this case, the attachments that I said I wanted to keep are not very useful. That is not a problem, I will simply delete them. Just click on the attachment you want to delete to activate it, and delete it by clicking Delete on the keyboard, or use the Delete button in the Workstep window. The patient name I will keep, but I will place it a bit different and change the text a little. I activate it by clicking it, and I perform the changes I want. I continue with Next, and the fixation guide is merged. After the merge is finished, I can do some free-forming of the fixation guide if needed. Since I did some free-forming already in the Edit Mesh step earlier, there is no need to do further changes in this case. I continue with Next, and the surgical guide result files are written. I now have a fixation guide that will be placed in the patient's mouth together with the bite index to find the position for the anchor pins. When the anchor pin holes have been drilled, the fixation guide is taken out and the surgical guide is put in and fixated in the right position with the fixation pins. Let's open the report with this button. In the surgical guide protocol, we have a nice image of both the surgical guide and the fixation guide. Below, there is a schematic diagram illustrating the information that is included in the report. The following pages include information about implant, sleeve and kit to be used. And at the end, you also find additional information to the implants, kit and sleeve if the manufacturer has supplied such information. If we look in the project directory, we'll find two STL files, one for the surgical guide and one for the fixation guide, that can be sent for production. Here you also find the protocols. Verify the surgical guide manufacturing process and the surgical guide before using it for the treatment of patients. Now let's go back and look at the design workflow Use Prosthesis. When I select Use Prosthesis, I don't need to design a surgical guide bottom or top. Instead, I get the denture shape as basic shape for my guide, and the next step is the attachment step. If I know already from the beginning that I will use the prosthesis for my surgical guide design, I can make sure to create room for the tools using the clearance above cylinder during the design sleeve mount step. I can also, in the attachment step, use the window attachments to create the needed space and at the same time make sure to keep enough of the bite to fixate the guide with the bite index properly in the patient's mouth. I continue with Next. If I after the merge see that there is no need for a fixation guide, I just click Next and can do some free-forming if needed. I can of course also create a fixation guide if I want to. In the end, if I don't create a fixation guide, I get the one guide STL, and the report looks like this. This surgical guide will then be placed in the patient's mouth with the bite index to find the correct position. The anchor pins are placed and the implant surgery can start. Thank you for watching.